Quantum key distribution is a method of generating secure keys for encryption using fundamental quantum mechanics principles. Due to the nature of quantum mechanics, QKD can detect if an outside party learns of the secret key, making it incredibly secure. QKD provides a more secure method for encrypting information. As quantum computers improve, classical encryption methods will no longer be suitable for protecting highly sensitive data.
KeyNet is a startup comprised of engineers and scientists pioneering quantum key distribution from satellites. KeyNet aims to design a module capable of performing quantum key distribution from a satellite using single photons. They will sell this module to satellite operators in order to use QKD to encrypt their sensitive data.
A laser beacon utilizes a laser to find the precise location or orientation of a satellite from a ground station.
In order for KeyNet to propose single-photon QKD device to function, it requires a very precise link. A laser beacon has been designed for this purpose. It must adhere to strict volume and power limits while maintaining an adequate link with the ground station.
The laser beacon module was limited to be 90 mm in length, 45 mm in width, and 30 mm in height. It must securely house all of the electronics as well as the laser and lens. Shown here is the full assembly of the laser beacon module. The green square represents the PCB and electronics, while the micro D9 module connector is shown at the rear of the device. The laser and lens must be precisely aligned for optimal performance. The mounting mechanism must be able to adjust their alignment, which is accomplished using the precision threaded rods. Rotation of the rods allow up to 1 mm of travel in either direction along the X and Y axis. The rotation of the cylindrical lens housing permits travel along the Z axis.
Considering the large distance from the satellite to the ground station, the laser will need to focus to ensure adequate signal strength. This is accomplished by using a lens to focus the beam to a narrow divergence angle.
Many commercial lasers were considered to function as a laser beacon, mainly in the near-infrared wavelength range. A 1064 nanometer wavelength diode laser was chosen for the final design.
To ensure the overall system was feasible, ground station detectors were researched for the wavelengths of the lasers being explored. A signal-to-noise ratio of 10 was considered the bare minimum for the link to be viable. A minimum observable power for each detector was then calculated.
A link budget is a calculation that accounts for all gains and losses along a signal's propagation path. An important consideration is atmospheric attenuation, which is highly wavelength dependent. These effects are combined to calculate the laser power observed at the ground station.
The space environment is very damaging to electronics, especially radiation. A microcontroller unit was selected which has successfully operated on previous satellite missions. Components also must be selected with margin so that they can be operated well below their operational limits. This allows for an improved operating lifetime, crucial for satellite missions which will be operating for years. The laser diode is a very sensitive piece of equipment and needs precise electronics to operate it. A laser driver is required to ensure the laser diode receives necessary voltage and current so that it operates at the required optical power. The laser driver must also ensure the laser diode safely starts up and shuts down.
Software is needed to control the laser from the microcontroller. It will modulate at a specific frequency and only turn on at certain times. The microcontroller must communicate with the rest of the satellite to share health and telemetry as well as receive instructions. The microcontroller was programmed to communicate with the satellite's onboard computer through I2C. We integrated different controllable modes of operation, which allowed us to vary the behavior of the laser beacon module.
Q-Link 1064 has successfully designed this laser beacon module to allow for KeyNet's quantum key distribution to function optimally. This module will help pave the way for a more securely encrypted future.